So today's video is going to be about my 3D printed line array speaker here. So the Enclosure is fully 3D printed. It's printed out of PETG. The speakers, unfortunately, are not 3D printed. They are bought. I bought them on some closeout warehouse buyout sale, so that it was super cheap to do this. I'll post the links up to where I bought these. I don't know if you'll get them for the same price that I did, but they were super cheap, so it made this project very, very cheaply replicatable. So the main component of the 3D printed line array is going to be the oval speaker. I'll put up all the specs for that speaker here on the screen so you can kind of see what those are. And then the tweeter on this line array is a piezo style tweeter. And a piezo tweeter is different from a regular speaker in that it has a piezoelectric crystal inside that allows it to vibrate and make frequencies. This can be very harsh sounding, so to kind of combat that, I installed a 5000 hertz high pass filter during the installation of the line array here. And that just applies to the tweeters. So everything 5000 hertz and below should be greatly reduced in the amount of signal that gets sent to the tweeters. So the line array uses 8 of the oval speakers and 6 of the tweeters. I chose 8 of the oval speakers as they're 16 ohm speakers, and using the 16 ohm speaker, I can wire them in a multitude of different ways to achieve different ohm ratings at the very end that the amplifier sees. I chose to go the route that gets me to 8 ohms, but I also found a way to get me down to 2 ohms, but finding a 2 ohm stable amplifier was just more trouble than it was worth. Considering that these speakers only are good for 5 watts a piece, 8 of them, that should be 40 watts for each one, or each channel. So 40 watts for the main channel and 40 watts for the tweeter channel is more than enough power for these. And I've tried them on as little as 1 watt of power, and they're still very loud speakers. Okay, so moving on to some more of the design of the actual enclosure. So it was built in 2 parts. The actual enclosure was, as I don't have a printer that big. So it was built in 2 parts and then epoxied together. There was a lip on it to kind of help me center. And then I added these ridges into the front face and side face to kind of hide that seam gap. So I just put these little, I guess, chamfered edges and kind of ran them down and out the side, and it just helps me really hide that seam edge and make it seem more seamless into the speaker, and it kind of gives it a little bit of break on the big solid flat surfaces. The speaker is attached to the base via a couple of 20mm aluminum tubes. They serve no purpose other than just to separate the base from the speaker itself. I just like kind of the negative space there. The base itself was printed hollow and then filled with self-leveling like cement for flooring to kind of just give it a bunch of just mass, so that way they're very stable. I mean, as you can see, they're very, very stable speakers. So putting all that weight down low really just brought the center of gravity down and made it where they didn't want to tip over so much, because they're very narrow and tall, and I wanted them to be able to withstand a little bit of tipping and movement of desks and whatnot, or if I bump them, I don't want them to just fall over and break. So that was kind of the goal there. But I filled them with that self-leveling, and then came back in with just some filler, filled in all the gaps that didn't get filled in, sanded them smooth, and then put felt on the bottom, so that way they were nice and smooth and they didn't screw up any desks or surfaces that I put them on. So the inside of the speakers, the tweeters are all wired in parallel, which means the positive and negative just jump positive and negative, positive and negative, positive and negative to all the speakers. And what that does is it reduces the actual ohmage of the tweeter. But since these are piezo tweeters, the ohms on them were well into the 100,000 ohm range. And so you can wire them multiples of those in parallel without ever running a risk of dropping the ohm too low on your drivers to the amplifier that would cause your amplifier to overheat or short out. So just running them in a bunch of parallels doesn't cause any damage to the amplifier. The main speakers, though, the oval ones, I had to be more careful with them, as you can get to really low ohmage, like 1 ohm and half ohm, and that will really damage amplifiers and cause them to overheat. My amplifier is 4 ohm stable, so I could have went as low as 4 ohm, but I just decided to go with 8 ohm. It's just kind of a nice, easy number, and a lot of home theater amplifiers will support 8 ohm loads as well. So to get to the 8 ohm load, I had each one of the oval speakers is 16 ohms, and I wired it into 4 pairs in parallel, or in series. So that would mean that I ran through a 16 ohm and a 16 ohm to get a 32 ohm load out of each pair. And then I wired the 4 pairs all in parallel, which got me down to an 8 ohm load. I'll put the formulas up on the screen so you can kind of see how that works, but when you're just doing multiples of 2, it's very easy. Series, you just add them together, and parallel is the total ohmage divided by the number you put in. When you start doing different loads together, though, you have to start using some of these formulas, as things get a little weird when you start doing series parallel wiring. But all the wiring comes together on the back little nuts that I have on the outside of it, and from there they run down to the amplifier. One last thing on the construction of the line array speakers is the back of them is just screwed together. I wanted to do some sort of slide together, snap together with like a gasket, but I kind of just cheated my way out of that, and I use blue tack around the outside of the speaker, as I have on my other speakers, to kind of seal it off, and then I just put it together with some standard M3 screws. And I hope that you guys aren't too mad about me for just screwing right into plastic. I really wanted to do thread inserts, but I didn't really want to put that many thread inserts into these, and then I was worried about how much on the outside of the thread inserts I would have left, and I didn't want to burn through on the sides when I was inserting them either, so I just kind of stuck with plastic threads. For what I do, it should work just fine. So yeah. So now we're going to move on to some of the testing, and we'll look at some charts, and yeah, so that's kind of the next steps here, is look at the charts, and then we'll do some listening to it as well, some play testing. So yeah, hopefully you guys enjoy. Moving on to the graphs, but first a word about today's sponsor. PCBWay, a quality PCB manufacturer and dedicated collaborator for electronic projects. Known for top quality, quick service, and exceptional support, they're the choice for enthusiasts, students, and pros. Even better, they offer new users 10 high-quality 100 by 100mm PCBs for just $0, users covering only shipping. Explore your passion without breaking the bank. Visit PCBWay.com now to turn your ideas into reality. Okay, now over in REW, checking out the graphs that were created by a single line array speaker. So this is just one speaker. And this is near field. This is about 8 inches away from the line array itself, directly in line with it. The microphone's position is just about center of the line array. So we can see that it starts off not doing very well at the very low end of the sound, but that's to be expected as these are very tiny speakers. And then we gradually start gaining some better output from the speaker up until we hit right around 300 hertz, where it kind of peaks out. The peak on this is pretty close to 100 SPL decibels, and this is only with 0.5 volts input to it. 0.5 volts into an 8 ohm circuit. So, and then it kind of tapers off a little bit, and then we see some, I don't know if this is distortion or what's going on at the end here, but near field it has these big dips and spikes here at the very end at the high range of stuff. So, and then if we look right here at 5K, this is right around where those tweeters are actually starting to come in. So below 5K, they're being attenuated down, and I don't know what the exact attenuation is on that particular high-pass filter. I don't know if it's a -6 decibel or a -12 decibel per octave, but it's a pretty severe attenuation on it below 5,000 hertz. So everything from about 5K up is both of them performing, and everything from 5K down is just that's just the oval speakers performing, because this tweeter's been attenuated. So, but now I'm going to show you the 1 meter graph. So this is taken, or it's not exactly 1 meter, it's like 6 feet something inches away, but pretty close to a meter away, straight on with the speaker. And as we can see, it's not as peaky out here towards the higher frequencies, but it is more peaky down here in the lower frequencies. We have some major drop-offs. And so I don't know if that's just a product of the different spacings or what, but as we can see, there is some definite dips happening in this. And this is again at the same 0.5 volt input into an 8 ohm speaker. So, and then again at 5,000 hertz, we can see kind of another peak almost showing up right there, because that's kind of when that tweeter takes over. So this might indicate that that's where that tweeter is kind of coming into the sound right there. So, and then it kind of tapers off as we get closer to 20,000 hertz. I'll overlay the two graphs now, if I can. So there's kind of the difference between near field and about a meter out. So near field would be the green line, and the further out is the red line. So near field is obviously closer. As we get further away from stuff, sound tends to kind of fall off, I believe, in a square or cube rate. I don't remember which one, but it falls off exponentially either way. Okay, so that's about all that I have for today. I don't know if it's going to be a super long video, but it was a very fun project to do. And I plan on using these line array speakers as the main kind of audio in the 4.1 or 5.1 system that I'm going to be building for my office here. I'm getting ready to put a computer together, and then this will kind of be the tower speakers on either side of my monitor setup. So that's kind of the end use of these, is to be just the main kind of channel for that. I'm really leaning towards a 4.1 system, as I don't really know too much about 5.1 systems and how to set up that center channel. But the back system is going to be probably my version 13 3D printed speakers, and those will be my back channel, and then my front channel will be these. And then I've currently got a subwoofer in the works for the 0.1 in that system. So yeah, keep an eye out for that. It'll be coming down the video line here before too long.